Hello. Paraterraforming another planet, in this example Mars, is building megadomes filled with air that envelops a whole city, meaning living, working, and doing agriculture inside the dome. Also, domes filled with air brings the danger of structural failures and losing all the breathable atmosphere. Small holes aren't an issue because doesn't bring the danger of explosive decompression and can be patched before it becomes an issue. The problem lies in catastrophic failure of the dome that brings death to the inhabitants found in the open. What I am thinking about is a solution of mitigating the danger of catastrophic collapse and losing all the atmosphere by using a pit, a canyon, or a crater large enough that it contains its own atmosphere, held in place by gravity, as reaching at the top equalizes the pressure of the Martian atmosphere or slightly higher to sustain the weight of the roof. The roof will be needed to keep out the mixing of two atmospheres together in case of Mars that is mainly of carbon dioxide. The collapse of the roof will not be a colony extinction event because difference in pressure will be minimal that will give time to put a temporary roof or patch it in several hours or even days. Now, let's talk about the concept of atmospheric scale height, and it is the height of which the pressure drops by a factor of E, meaning by 2.718 times. So, for Mars atmospheric pressure to reach the pressure of 1 bar like Earth, you need 5 times scale height or 4 times if you use a roof sustained by the pressure with a weight around 100 kilograms per square meter. Now, how deep has to be the pit to sustain its own atmosphere? So for a pit that has atmospheric composition like Earth, that has a scalar height of 20,809 meters on Mars, and to match the pressure of Mars atmosphere at the top will be 100 kilometers deep or 80 kilometers with a roof. Even for Mars that has lower gravity, where volcanoes can reach 21 kilometers and canyons 7 kilometers deep, is a bit too much. But if we change the atmospheric composition by using heavier molecular mass compounds, we'll increase the density for a given pressure and temperature, and that will decrease the atmospheric scale height accordingly. So for xenon, the heaviest atom, that is a gas at room temperature and it's not radioactive, and the most important is chemical inert. So for an atmosphere of 78% xenon, 21% oxygen and 600 parts per million CO2 and the rest of 0.9% nitrogen, the atmospheric scale height is 5,363 meters, meaning the pit has to be minimum of 21.5 kilometers deep to 27 kilometers maximum. A great improvement of over 80 kilometers for an atmospheric composition like Earth. But the problem with xenon is it is very rare, and being very rare makes it very expensive. Another heavy gas that is non-toxic is sulfur hexafluoride, with a molecular mass higher than the xenon makes it a little better, reducing the scale height to 4,880 meters and reducing pit depth to minimum of 19.5 kilometers and 24.5 kilometers maximum. Of course, using a very potent greenhouse as a main composition of the atmosphere means that the roof must reflect back infrared radiation and selecting for visible light to pass through, thus reducing the solar irradiance at the ground level. Future improvements. If a heavier, non-toxic gas with a molecular mass of 250 or above is discovered, it will bring the scale height to 3,000 meters or lower, bringing the total depth to 12,000 meters and 15,000 meters maximum. To be able to give up the need of a roof and using dams that encircle the colony, dams that are tens of kilometers high and be able to contain 1 bar atmospheric pressure. Partial pressure of oxygen and nitrogen must be equal with the other side, meaning outside has to have an atmosphere with oxygen's partial pressure of 0.21 bar and nitrogen partial pressure of 0.01 bar. For the filler gas, as sulfur hexafluoride will not diffuse over the dam if there is a zone high enough that the temperature is low enough to make partial pressure zero. But oxygen and nitrogen have a very low boiling point that this kind of zone is not possible.